right, so GIS 1, in the readings for this chapter, Price goes through a lot of terminology. She talks about the kind of data that we're going to be using. She talks about spatial data being georeferenced, which means that's connected to some kind of location. So she's going to go through that in the readings. She also discusses, and for some of you this will be a review, the difference between the vector model and the raster model of data, where vector model is points, lines, and polygons. A point is usually one XY coordinate. A line is at minimum 2. So there's one at each end of the line, and then a polygon has to be at least 4. Yeah, at least 4. Because the first and the closing vertex of a polygon is the beginning vertex of a polygon. So if I want to do a triangle, I actually have 4 vertices for a triangle. One of the benefits of the vector model is that it actively represents the surface. So if I want to make a map of LCC or the Learning Garden, I want to use the vector model because I could get very detailed outlines of the buildings and the trees and the roads. I'm looking at a scale that's a pretty large scale, right? Not a lot of reduction. If I use raster data, I'm going to be looking at just grids and pixels, so squares of data. So the first image that we saw this morning, the map of the purple, that was probably, oh, I know it was. It was a raster image taken from remote sensed Landsat images. And raster models are great for doing high-level modeling. So I want to figure out where a watershed, where that stream channel is in a watershed and how fast the water is going to flow or where the slopes are. Raster models are great. They're also great for large areas of data, right? So if I want a vegetation map of the state, the map that we have, if we look on the Geospatial Data Clearinghouse, is raster. So she goes through all of that. Okay. She also briefly reviews coordinate systems. The fact that we have 2 different concepts of coordinate systems when we're working with GIS data. So we have what's called a geographic coordinate system, which is just bare latitude and longitude. Okay? And latitude and longitude is great. We use that often in our GPSs. It's transferable. But you can't do much analysis with data that's in a geographic coordinate system because the linear measurement or the area measurement is in decimal degrees of angles. So it has no meaning. So if you have data that you want to accurately measure distance or create a buffer or do any kind of volume measurement, you need that data to be in a projected coordinate system. Okay? And ArcGIS has the ability to what they call project on the fly. So it will take 2 projections and make them line up so that so the data lines up where it should. Okay? If you're doing very detailed mapping, you don't want to rely on projections on the fly. You want to actually reproject all of your data to have it in the same projected coordinate system. So she goes through a little bit about latitude and longitude. She also runs through map scale. Okay, so all of this we covered in 151. Talks about the reduction, a ratio scale, a graphic scale, and then people still use a verbal scale. And then there's the always confusing large scale versus small scale. And what are we really talking about when we do that? So she goes through all of those. She spends some time, this is a huge chapter actually, going through data quality. And we'll talk about that later in the term in more detail, and especially in 246 we go into accuracy, the different ways that data can be spatially accurate and thematically accurate, and then talks about precision and resolution. Okay. One of the things that we'll focus on this term is data citation. We didn't do much of that in 151, but in 245 we really need to start citing where our data comes from, and because a lot of this is canned, it makes it a little more tricky. But she gives you kind of citation formats to use, especially when you create your final project each week, your final map. Make sure your citations are good and your projection information, because that's something an employer is going to look at. Can he do the detailed stuff? Can she follow through with that on a map? Yes, Justin.
Can I interject something?
Yes.
Because you keep bringing up that future and that employer.
Yes, sir.
One of the classes I'm taking is about research and critical thinking,
Uh-huh.
and they're developing e-portfolio, and academically people are moving toward e-portfolio.
Yeah. And I think GIS maps just really lend themselves really well to an e-portfolio, which is basically kind of your own personal website with your syllabus, your resume and your work samples online, which would be great. Don't put it on your Facebook page. Okay. So Price goes through data files, and so of the things that we've talked about so far, projections, you really need to understand coordinate systems as they relate to geographic coordinate systems versus a projected coordinate system. You really need to understand latitude and longitude, and the different types of data files that are available in GIS. And some of these have changed over time. So we're going to work a lot in geodatabases, and they're a relatively new aspect of GIS. Maybe in the last 5 years they've become pretty standard. A geodatabase we lovingly call the tuna can. And the tuna can is a package that just kind of holds all your data. It's easy to transfer to other people. You don't lose pieces of your data. It's kind of built for that storage, has high-level storage. Inside a geodatabase, you might have what's called a featured data set. And the featured data set looks like these three overlapping file folders. And a featured data set is really great for enforcing a projection. So when I create a featured data set, I tell the featured data set what data projection I want to use, and any data I put in there is automatically reprojected to that projection. So this is a way that I can kind of keep my data clean and keep things lined up really well. You can also have standalone features called feature classes, and these are all kind of vector data. Some of the older files that we'll run into are shape files. And shape files were kind of the second generation spatial data file. These are standalone little files. They don't have topology, which means that if I have a bunch of polygons that are next to each other, I can actually edit those polygons and corrupt them so that I create spaces or I overlap them. If topology is enforced, like you can in some of the featured data classes, featured data sets, then if I move one shapefile, the other moves with it. So, for example, when people are working on census tracts and they have a large area that they've split up and subdivided, so they can cut those and subdivide them, and they stay in alignment with each other. If it were a shapefile, I could cut them up and subdivide them, but I might actually nudge one away from another one, and then I would have data that wasn't really accurate. So shapefiles are great, though. People still use them. One shapefile has to have at least 4 supporting files with it. And so if I have 10 shapefiles in my folder, I would actually have at least 40 files and maybe 80 files, okay, because you can have a lot of support. So they're a little messier to use. And so when I'm going to send Caitlin a shapefile, I have to make sure that I get all the pieces of that shapefile, put it in a folder, zip it up, and send it to her. And it's really easy to kind of drop one or not get them all in. That's one of the reasons featured data sets and geodatabases are much better at that. ArcGIS can also look at tables. So it's will import things called DBS, which is DBase 4 tables. It can look at CSVs. Well, it says it can. It doesn't always. And it should be able to open up Excel files. Again, ArcGIS says it can open all of these, and I've had lots of trouble opening those. One of the tricks with a table is if I import a table into a geodatabase, it tends to kind of fix it, and I can open it up where I might not be able to open one up freely. That's the kind of stuff that we will problem solve and troubleshoot throughout the term. She'll give us an assignment, it won't work, we'll have to kind of figure out what's going on. It might be her directions, it might be a corrupt file, and we'll get through that. The other data format are raster data. So all the shape files, the feature classes, those are all vector data. The raster data are grid files, and then the oldest file type is called a coverage. And she'll have you open a few coverages to look at the structure of a coverage. So, for example, if I have a polygon of city areas, that coverage has to have supporting files where it has an arc, so it shows me all of the lines, the nodes, and the labels all as separate features in a coverage. So she'll go through reviewing all of that data. ArcGIS, actually I didn't do the ArcGIS online. It's kind of considered a family of products. That's how they like to talk about it. And we're going to start out, you're going to start out using a file called ArcCatalog. And ArcCatalog looks like a little file folder with a globe and it's on the bottom bar of your computer. And ArcCatalog right now is kind of two files. There's an ArcCatalog that shows up when you open up your ArcMap interface, and then there's an ArcCatalog that's a standalone file. And my understanding is that in 10.1, ArcCatalog as a standalone is going away completely, and it will all be embedded in ArcGIS. So that's something I think to look forward to. ArcMap is the file that is kind of the less robust program. And then ArcEditor is a little more robust than ArcMap, and we're using ArcInfo, which is the highest level GIS package. So in Chapter 1, she wants to have you learn everything that we did in 151 in like an hour or two. And then she wants to talk about how to connect to data folders, file structure, looking at geometry and attributes, and then file types. And it's really, really important. File structure and knowing where your data is. How many people will attest to being able to find your data is maybe one of the hardest and yet most important pieces of ArcGIS? How many people have not been able to find their data when they opened a project? Oh, come on, come on. Everybody. Okay, so that's kind of the goal of the chapter. I know. Sometimes it will go into the temporary file. So when you open ArcCatalog, one of the benefits of ArcCatalog is you can quickly preview data. So you can click on the Contents tab, you can click on the Preview tab, you can look at the geography. So right now I've got this in Preview under Geography, and I'm looking at point data. And this is sometimes nice just to make sure that the data is actually there. You know, sometimes I'll get a file and it's corrupted and I don't know what it is and I don't see it there. So she's going to have you look at ArcCatalog that way. Then you can, instead of clicking geography, you could click the table function down here at the bottom, and you can look at the attribute table that's associated. So rather than opening up ArcGIS and loading all of these different files, ArcCatalog lets me look at all of the data really easily and kind of see which files I might want to use, or if they have the field I'm looking for. You can also edit these fields in ArcCatalog. So I could add a field. Let's say I want to make a new field and add a couple layers together. I can do that in ArcCatalog, and we did some of that in ArcGIS last term. Okay. couple glitches in the software. I don't know if it's the tutorial or the exercise. She's going to ask you to look at the metadata. And metadata is critically important. It is the most hated aspect of ArcGIS, and it is probably the most glaringly absent piece of ArcGIS. Most of the data that we have has no metadata. I don't know where they got it. I don't know what's been done to it. I don't know where it came from. People don't like doing metadata. They don't, or they'll copy a shapefile and send it, and they don't take the metadata with it. So ArcGIS was trying to get a metadata tab, but it's corrupted in this version, and we can't really look at the metadata. So when you get to that part with price, just ignore it and move on. And then one of the things that advisors have asked me to stress is the fact that when we open up ArcMap, so I'm going to open up the globe with the magnifying glass on it. ArcMap is just a tool to visualize and to bring data in to look at it, to bring data in to manipulate it, but the data is not in ArcMap. The data, so let me just add something here. We've got all that price data, right, that I just downloaded. So I'm going to open up the ArcMap catalog, and I'm going to go File Connections Desktop, and here I am looking at price. So here is all the data, and I'm going to pull in Austin. I'm going to open up the geodatabase and the feature class, and I'm going to pull in that. I'm going to pin that, and I'm also going to pull in parcels. Okay, so I am looking at this data in ArcMap, and ArcMap will let me create a map with the layout tool. It will let me actually select and edit. I can do a lot of processing, but this is just kind of the window. The actual data is always right here, right? That's where it came from, and I can tell that by choosing the list by source. So I can see that that's where my data is. So if I save this, file save as desktop test, and I go home, and I grab this and put this in my flash drive and go home, I'm not going to have anything when I get home, right? Because I'm just got this window that says, go to the lab into that desktop and grab that data, right? So it's really important when you, actually, let me just throw this away. Yes. Okay, hold on. I'm going to close ArcMap. Really? Oh. Okay, I'm going to close this. Yes, save the test. Close that, close that. Okay, so let's say let's hope this works. I'm going to take that in the trash can. And so let's say I go home, I open up my flash drive, and this is what I'm going to get. Because my data is not with me, right? I've taken the data away. It can't connect to the path. I'm going to get these red exclamation points, and I have a problem there. So it's really important to know this is kind of just an operating window that lets you manipulate, view, see, but all the action is happening to that data in the file in the geodatabase. All right, so let's see, am I almost done? Are we almost ready? Yes. Okay, so I'm going to have you're welcome to stay and finish it. You can go and finish it, but you're going to work through the tutorial in Chapter 1. One of the things I'm going to ask you to do, oh, wait, no, I have to talk about, hold on, where's Moodle? Wait, Moodle. Okay, in Moodle, I have a tutorial guide that hopefully helps talk about some things that aren't working, okay? So I talk about set up a folder, right? and start Price Chapter 1, open the Word document, so it gets you kind of started on that. And then when you get to page 29, that description tab is not working. So these are things that we've already kind of figured out when we go through. And I want you to take a screenshot of your file structure. So I want to see what your files look like so that I know that you set them up right. So that's the tutorial part. Let's go back here. Is Moodle back up? Come on. All right, hold on. Where did Moodle go? Oh, here it is. And then when you get to the exercises, and we'll talk more about that on Tuesday. Again, some of the exercises, there's some hints, some things that didn't work right. So I would kind of go through, maybe star these in the book so you know when you get to that one to go look at the cheat sheet for some help. And then there's a challenge question. I want you to make your first map. And I have an example of what the map should look like. And then there is a very short little Jing video in how to go about making a map if you haven't done one in a while. Okay? So that gets us through. Kind of, you've got some time to start working on this if you want. Any questions so far? Yes, Justin.
Where's that little box that makes sure the relationships?
Ah, yeah, okay. All right, good remembering. So this is a problem, or doesn't have to be. I threw my data away, so I can't really do it. But let's say I'm working at home on my C drive, and I have my flash drive at home, and I'm working at home, and at home, let's say it's called the D drive, right? And I set it all up on the flash drive. I bring my flash drive and I plug it in to work. At work or at school, that flash drive might be called the G drive. So ArcGIS is looking for the D drive. You don't have a D drive. You have a G drive. So now you've kind of confused it. So one thing you can do to help that, under File, Map Document Properties, there is a box you can check that says Store Relative Pathways. And this means as long as your data doesn't change location as far as moving out of a folder from one folder to another, it doesn't matter what the drive is called, G, C, B, A, doesn't matter. As long as my data is where it was relatively. Like if it's all in the 245 folder, doesn't matter what I call the drive. So if you set that every time you make a map in ArcGIS, you're going to be a lot happier. That said, it works about 95% of the time, and every once in a while, even though you've set that, it can't find your data, which is not an emergency. We'll clean that up later. Okay, any other questions? Good questions.